Hi, everyone. So I'd like to talk to you a little bit today about how we are redefining the edge with AWS. My name is Glemmstead, and I'm the head of business development here at AWS Worldwide Public Sectors for edge computing. I want to talk to you today about services like Outpost, Wavelength, local zones, and the Snow family. Some of this might be unknown names to some of you, or it might be familiar names. But first of all, what is edge computing and what can it enable? Well, it's all about bringing the capabilities of AWS closer to the users, closer to other systems that you might be integrated with, so that you can transform legacy environments, legacy infrastructure, and come up with new use cases or novel use cases that weren't possible before without having this infrastructure available. So the whole idea here is to be able to develop once and deploy anywhere, not just in the region, but in customer data centers, in forward bases, on Humvees, on boats, in UAVs, whatever it is, you should be able to develop once and deploy anywhere. So I'm going to go through a few of our services, and this first slide might be a little bit overwhelming. But don't worry, as I say, stay calm. I'm going to go all through this in systematic fashion and take you through all this and how we can cover all of these services and use cases basically anywhere in the world. So what we're going to do is we're going to look at this from the outside in. So from the furthest edge, I mean, we're talking disconnected. It could be in a desert. It could be hovering underneath a UAV. And we're going to start really at the far end and then work our way inwards. So the furthest edge here is really the Snow family. And the Snow family consists of a lot of different services or a lot of different infrastructure that can operate in disconnected environments, in harsh environments. And we just brought out a new device here as well that I want to talk a little bit extra about. So first of all, the Snow family is used for two main use cases. One is about data migration. So let's say you need to move a lot of data from point A to point B, and you want to move it into the cloud, for example, from a customer data center or from other places where you're capturing all this data. But you might not have the connectivity to do so. Or you have a connectivity, but you're using it for other things. You don't really want to load it with you moving all this data. So what you can do there is you can use our devices like Snowball Edge and Snowcone and some of the other ones to move this data in an offline fashion. The other use case for the Snow family is edge computing. So the challenge here could be that you have no connectivity or there's a very low connectivity, high latency, sporadic connectivity. Or it could be a very harsh environment, like in a desert, or on a ship, for example, or on a boat. There's a lot of different use cases here as well, where you need to have some kind of edge computing. You need to have compute closer to where the data is captured and do something with the data straight away. But it's definitely outside a normal data center environment. So some of the places where we do see edge computing used quite a bit is some of these areas. So anything from content distribution, you need to get it out to a lot of different sites, for example, from the cloud. It's obviously a tactical edge. IoT, industrial and healthcare, field hospitals, transportation, logistics, autonomous vehicles. All these are places where we see a lot of edge computing needs and where the Snow family comes in. I just thought I'd talk a little bit about a few use cases that our customers are using Snow for, just to give you a little bit of background on what it can be used for. So one of our customers, Philips, are using Snow to support their medical devices or medical machines in hospitals. They need to have some kind of capability close to these devices to capture the data and maybe do some initial analysis on the images that are captured and to allow doctors to work with this data. Now, they could just use legacy hardware for this, but when you're scaling this into thousands of various different locations, you need to have a repeatable way that you can deploy this with things that you've developed in the cloud or you developed through a POC, and then you want to deploy to a lot of different locations. And that's what the Snow family allowed them to do, where they can order a Snowball Edge, for example. I'll get back to what that is, and get it shipped directly to the hospital or the location where it's needed, preloaded with the software that's going to run on top, and ready to capture data, and then allow the physician, for example, to work with this data through their systems. Another use case is for the NGA. They're using it as part of Odyssey to do some analysis. Here's used more in a clustered facility as well, where we can tie several of these together, both for latency, capacity, and for fault tolerance. I'll come back a little bit more to that as well, but that's one of the ways you can do it. Capture data, do some analysis on it. Here you're doing quite heavy analysis on it, and that's where it can be tied together. Novetta, on the other hand, are using it in that disaster response and IoT in new builds, houses, for example, to capture sensor data and do analysis on that in environments where you would not necessarily normally deploy computing capacity, or you'd have to find some way of doing that. That's where it's very easy to just deploy a Snowball Edge and do the processing. Dirt, as part of Help NGO, was another time where we deployed Snowball Edge. You can see a little bit of the size of the Snowball Edge there in the middle, at the bottom in the picture. It was used for capturing images and everything around that when Hurricane Dorian, Category 5 storm, hit the Bahamas in September of last year. They were engaged to help the humanitarian response activities, capture data, and do some analysis on that, and then transport that into the cloud. Obviously, connectivity is not easy in a disaster response scenario, and you have to ship these devices. You have to hand them off, transport them through some kind of logistical channels. So that's where Snowball Edge worked out well. So the Snow family, as I said, it consisted up to a couple of weeks ago of Snowball Edge, which comes in two flavors. So I'll get back to that. It's about the size of a large desktop tower, certified for single person carry. It's 150 pounds. And then you have Snowmobile, which is basically a big truck full of hard drives, to simplify it. They say, don't underestimate the bandwidth and the capacity of a truck full of hard drives hurling at highway speeds to the nearest AWS data center. It could actually be faster than transferring the data online when you're talking about transferring massive amounts of data. So that's a capability we have there as well. As I said, Snowball Edge, which is definitely the more deployed version of the Snow family, comes in two different flavors. So you got a compute optimized flavor and a storage optimized flavor. The compute optimized has more compute capacity, less storage. But if you're doing some kind of analysis out there that you need some heavy churn on, you need to work through that data and maybe respond to that straight away, that might be a good solution for that. It can also come with a GPU. So if you have machine learning applications that are working on analysis of video or images, for example, that could also be a good choice there to do that before you send it to the cloud. So you do the initial analysis out there, just churn it, and then instead of sending all the raw data up to the cloud, you only send the results and what you're really looking for. Storage optimized, on the other hand, has more storage capacity. Not as much compute, but there's still compute capacity there. So that's for slightly different use cases where you need to ingest a lot of data, for example. And then I said clustering. Clustering, if you need to tie together to have even more capabilities than what you can with a single Snowball Edge, you can time together and create larger clusters. But what I'm most excited about is actually our newest member of the Snow family, which is called Snowcone. You might have seen this over the last couple of weeks. We just launched it. It's got the same military-grade security. It's tested for harsh environments. You can do online or you can do offline data transfers. It does have some compute on here as well, so it could do some basic initial analysis, for example, of data, or to help run some services on the Snow device itself. So it's not just like a NAS, it's not just a little hard drive that you can send out to someone. It is definitely a fully capable solution that you can deploy AMIs and other services on that you've tested in the cloud, for example. It's very easy to develop that in the cloud, deploy it on one of these, and you could literally order 1,000 of them to 1,000 different addresses, and it would be shipped out ready to go. The size of these are about the size of a large tissue box. It's less than 5 pounds. It's easy for backpack carry as well. And because of this, it enables usage of AWS services in more locations than it's been possible so far. In one of the videos that you can see from the launch as well, I think it's also on YouTube, we strapped one of these to the other side of a UAV. And by doing that, we could fly around and collect data and do analysis of it straight away. Because it's also got Wi-Fi, you can transmit that data back even while it's collecting data and doing analysis. So that kind of takes care of the far edge, the Snow part of things. Like where these are the bad areas to operate in from a technology standpoint. They're not easy. It's often disconnected. And it's unreliable connectivity. But you need to have some applications out there. And along with our theory of develop once, deploy anywhere, that's what enables you to deploy in those kinds of locations. But let's say you do have a data center and you want to deploy more capabilities. You need something that's stronger. That's where Outpost comes in. So Outpost is designed to go into existing data centers in a forward base, for example, if it's more established, and it is an extension of the region of what we call AWS proper out into your data center. So Outposts is the same AWS design infrastructure. It's basically everything AWS, same APIs, same management console, same infrastructure that you would find in the region, and therefore you can manage it in exactly the same way. You can deploy things in exactly the same way that you did in the cloud. There's complete parity there. So if you can deploy something in the region, you can deploy it on an Outpost as a EC2, which is our virtual machines, and use EBS storage, for example. Some services are consumed locally on the Outpost itself, while others are consumed from the cloud as well. And we can also tie several of these together. It's also a fully managed service. It's not a product. And the way I describe that is that a fully managed service comes with people. It comes with operations, dashboards, and more importantly, it comes with alarms. So that if something happens that's unexpected, people get paged, and then they can do something with it so that they can restore the capabilities fully, and you can just keep using it. It's kind of the same way that you would do with the cloud itself or the region, in that when you deploy something in the region, you don't really think about what's underneath. You don't have to think about that because that's our job to make sure it runs. It's the same thing with Outposts. You don't have to run an Outpost. That's our job. We got to make sure that's available to you as capacity, and then you can just deploy whatever you need on top. The other thing is, as I said, it's a single pane of glass or a single pane of management for both this and whatever is running in the region. So that means the same people that are managing your AWS deployments can also manage the Outpost without any extra learning curve or anything extra around that. So what is the Outpost? Well, it's fully assembled racks. It's one or several, and they either are custom made or based on standardized SKUs that are available on our website. It's so that you can also chain several of these together into one logical outpost, and thereby get even more capacity to deploy things. As I said, they're fully assembled. We literally just roll them into your data center and connect them to power and networking, work with your people there, and then we make it available in your AWS accounts. Everything is obviously redundant, and it's designed for always on, always connected. Some of the use cases that we see most for Outpost is low latency. That's one of the general ones where for some reason you need to have something process things very quickly. It needs to be tightly coupled with other systems, and bringing that data all the way to the cloud and back again might actually be just too far. Local data processing is another one. If you're ingesting large amounts of data in a data center environment or integrated with Snow devices, for example, I'll get back to that. But if you're doing that kind of initial processing in your data center, you need to ingest a lot of data, do machine learning on it, or do some kind of other analysis before you send it to the cloud. That's where Outpost comes in. Another challenge that we've seen is with data residency. So in areas where we don't have regions and customers want to deploy some of our services, then it doesn't have to be either just a country, it could be a state, or it could be some other kind of restriction that says you have to keep data in a certain area. Outpost can be used for that. There is a little starter, a caveat, because the metadata does go back to the region, whether that region is somewhere like US East 1, like North Virginia, or it could be GovCloud for that matter, or any of our special regions. A couple of extra ones that we see quite a bit in public sector specifically is migration acceleration, where a customer is looking to move to the cloud, maybe over the longer term, but making that jump for especially tightly coupled applications where you have many different services working together on the same data, it just might become too much of an effort to move everything in one go. And they want to be able to have a way to move a little by a little. Now, instead of then trying to figure out how do we transfer this data back and forth all the time, you deploy an outpost and you start moving the applications over to the outpost. That way, if you choose at some point in the future to move that to the cloud, you can then pretty much just flick a switch and you can run in the cloud instead, or scale to the cloud for that matter. If you want to run things on premises and then scale under heavy usage to the cloud as well, to use that as a backup or a disaster recovery scenario. The last one is something that I affectionately call small, medium, big brain. It's about the integrated edge, where we're taking several of these services and using them together. We see this desire now from customers, and they started developing solutions around it, where you could have something like Snow Cone on in a car. You could have it in a backpack. You're doing initial data collection all the way out there, or you're using it to collect data and do some analysis on it. You're responding to it there and then, but you want to capture that raw data as well. So you capture it on the Snow Cone or Snowball Edge for that matter, and then you synchronize it with an outpost at a forward base, where you have much more capabilities. At that point, you can do even heavier analysis on it. Whether it's machine learning analysis, there's GPUs available there as well, and you can scale it much larger, which means you can do much deeper analysis on it. However, it does also have its limitations. So if you do that kind of cooperation, collaboration, synchronizing between the different Snow devices there, and then transfer it up to the cloud, up to the full region, you can then have access to hundreds of thousands of cores that you could deploy at will to do very, very deep analysis and to do global cooperation. And that kind of builds together that full transition from the really far edge. You have someone running around with a backpack with a Snow Cone, synchronizing with a Snowball Edge on a Humvee, for example, then going to a base. You're offloading the data there to an outpost, do some more churning of the data, maybe do some recognition, and then you send it over to the cloud and the region. where you really do that long-term analysis, archiving, and storage, and cooperation, collaboration. The availability of Outposts today it's in these countries. I'm not going to go through the full list, but just showing you the map here of where we have the capability to deploy Outposts today. This map is growing all the time. And just to mention that these can be hooked to the closest region, or it could be hooked to any other region as well, as long as it's within connectivity back to the mother region, so to speak, has a good reliable connectivity back and the latency isn't too long. It can be connected to any region within reach, not just the closest physical one. So that's just something I wanted to mention as well. The security aspect is always very, very important to us. One thing I wanted to mention with Outpost as well is because now it is, in a customer scenario, a customer-owned facility. Not saying that the security there is not as good as an AWS data center, but just because we don't own that security anymore, we wanted to create some more services around this and some more capabilities so that you can be sure that your data is fully secure on here. So there's obviously this tamper detection and things like that built into the hardware itself. All communication back to the region is always fully encrypted. But in addition, all the data on the Outpost itself is encrypted. And the way that this is handled is through what we call the Nitro framework. And the Nitro framework also includes a hardware key that is a part of every server that is deployed in an Outpost. So if for some reason that data needs to be shredded, or it needs, let's say it needs to be replaced and a new piece of hardware inserted in its place, this key will then be pulled out, and you can then take a screwdriver, put it on the bull's head in the back there. That sits over a screw that is on top of a microcontroller. The microcontroller holds the encryption key that holds the encryption key that encrypts the data that's stored on the Outpost. If you screw that in, the microcontroller shatters, and at that point, all that data is crypto shredded. It is unreadable from that point onwards. So we built that all the way into the Outpost itself, and that's also one of the reasons why we didn't bring out Outpost until now. Even though it's something we thought about for a long while, we wanted to make sure we could guarantee the same kind of levels of security that we could offer in the region itself. So quickly summarized, Outpost is there when you need low latency, you need data processing, you might need an integrated edge, and you want the same capabilities, the same infrastructure, the same APIs, the same controls as you would do in the region. You just need it in your data center or in your forward base, for example. That's where Outpost really comes in. So that took care of Outposts. Those I would say are probably the most fitting solutions right now for the kind of use cases that I understand that you're looking for. But I just want to mention as well local zones and Wavelength. Local zones, first of all, is now we're getting even closer to the region. This is, I wouldn't call it the region light, but it is definitely about bringing some of the capabilities into other areas where we don't have a region today. Local zones is when you need very low latency access, so single-digit milliseconds, and it has to span a specific geographic area. And we don't have a region there, and you don't have a data center there, for example, or you don't want to have a data center there. That's when local zones comes into play. We only have one that we launched so far. It's in Los Angeles. And the idea here, again, is that it's the same controls, the same management data plane. Everything is the same as what you would see in the cloud and in the region. Again, the thought of develop once and deploy anywhere is what we're trying to enable. The question I get a lot is, when do we do local zones versus an Outpost? The first thing is that local zones is shared capacity, kind of like in the region, while Outpost is dedicated capacity. Outpost is yours, and you kind of control it, all the capacity. Local zones are hosted by us in locations we've contracted, while outposts are placed in your data center or colo facility or anywhere else that you have a data center like environment where we can deploy it. The third thing, and this is probably the most important, local zones are still large. They're not as large as a region, but they're still very large. So they're not suitable for short-term cases. It's usually something that we're looking at forward for larger deployments, larger countries, but it's not something that can be used for a short-term use case. So if the roadmap doesn't exist, or if it's something that we're not planning on right now, I mean, we're not rolling these out everywhere. This is something that's going to be very tactically deployed. Outpost is something that can be deployed anywhere in any of the countries that we were just talking about, and it's up to you where you want to put them. So that's something that can be done at will today. The last thing is obviously that the local zones are pay-as-you-go, while outposts are term contracts where the capacity is dedicated to you for a certain time period. Okay. If you're not confused yet, let's add on one more thing. I think this is something that also could be very relevant as we start rolling out this service, and it's for mobile clients, mobile devices, a lot of IoT, for example. We're trying again now to enable our builders to build things that can be deployed in telco networks as well, and 5G networks. Again, with the same kind of thought, build it once or develop it once and you can deploy it anywhere. Wavelength is basically about deploying it through 5G networks and other networks where we're trying to build the capabilities, or rather you're trying to build the capabilities of your application and your workloads into the telco network. That enables you to provide very low latency access for applications such as AR, VR, for example, to a lot of different users across a bigger geographical area or in various cities where Wavelength is available. It provides the capacity where you can deploy applications directly into those networks. So we're trying to provide those applications, again, closer and closer to users and machines so that you can develop anything that needs ultra low latency access. Especially for things like augmented reality or AR. Unless you have very low latency, it's not going to provide a good experience for the end customer. And that's one of the things that we're enabling with Wavelength. It's not generally available yet. We're working with partners across the globe to deploy this. And it's slated for sometimes later this year. Again, I just wanted to mention that it's the same infrastructure that we have in the region. It's hosted in a telco network. It's managed and monitored by us. So again, you just use the capacity. It's our job to make sure it's there. It's our job to make sure it runs and it's available to you at any time that you need it. And it's fully integrated into the networks so that you can enable those very low latency access applications. So that explains that entire image. I hope that makes it a little bit clearer. I know it's a lot of things to take in, a lot of different services, but we're definitely with this enabling you to build things that can be deployed anywhere outside the region as well, not just in the region, but to create that integrated picture all the way from the really far reaches, like the desert, in a backpack somewhere, through the data center, through mobile access and Wavelength and 5G networks, all the way into the region, and enable that collaboration and joint analysis. So that's what I had today. As I said, my name is Evan Glemmstead, and I'm very happy to meet you all today. I think at this point, Shayn is taking over and is going to talk to you a little bit about Ground Station. Over to you, Shayn.
Thanks, Evan. Well, good afternoon, everybody. My name is Shayn Hawthorne from Amazon Web Services, and I'm coming to you from Colorado Springs, Colorado, and very happy to be a part of this great event. Thank you guys for having me. So I'm going to talk to you today about Amazon Web Services Ground Station, but first I wanted to tell you as well about a new organization that we just launched and we're very proud of. Teresa Carlson announced it on 30 June. I have her blog down here on the bottom if you'd like to go look at it. And basically, we are putting together now the Aerospace and Satellite Solutions business area so that we can really focus all of our efforts in a single effort into space. And we want to bring all of our AWS services and solutions to you into the space enterprise, both in the public sector as well as in the commercial sector. And we want to help work with you, our customers and our partners, to reimagine space system architectures and how you would do them in a web services way, how we can then help you transform your space enterprises, and then help you launch new services that can process space data both on the Earth, both in hybrid architectures like Evan was just talking about, and up in orbit in hybrid architectures. And then finally, we want to give you all the services that you need to support government missions and commercial missions. So as a background on what I'm going to talk to you about today, AWS Ground Station came about because we realized, and a lot of our customers that we worked with initially to work backwards told us that cloud offers a lot of value to satellite operators and data that they weren't realizing. We were working with tons of different satellite companies and discovered that most of them were operating on AWS, but they weren't getting the full advantage of AWS, and we wanted to help make that better experience for them by giving them scalable data processing. So if you launch one satellite, like say you're a small sat experiment out of SMDC, or whether you're going to launch a whole constellation of vehicles like the Space Development Agency, you could just come into AWS and only pay for what you need and scalably process only what you need for one satellite or what you needed for 24 or 30 or even thousands. And then you could take advantage of our storage, our data analytics, our machine learning and AI, and use that now to develop your products, and then use AWS's great network to move that data around the world, and with Ground Station, even up into space, and disseminate that information to where you need it. And to help facilitate that, we built our AWS ground stations and co-located them with AWS data centers around the world, so that they would offer unique architecture benefits to you, because by being right next to a data center and connected to it with the right kind of connectivity, you get very low latency services in the realm of seconds that you can get that information into the cloud and then immediately start using cloud services on that information and get products out to customers in seconds. So the value prop that I'd like you guys to think about would be, first off, with AWS Ground Station, you've got a global antenna network that's built on top of the security and infrastructure that AWS has put together for our entire regional construct and availability zones. And that's a great area for warfighters and the services like the Army, the Air Force, the Space Force to focus on, because those are the things that could benefit the government to be able to have this global network and all of this high security that you need to grow your architecture in a scalable way, but not have to pay for any of it, except for when you need the service, you actually come in and pay as a service and don't have to worry about it any other time. Then for the rest of the community, which is the contractors, the integrators, and our partners that are building the services and the applications that you need to support the warfighter, they now have access to the scalable ground processing, the network that we have, and our storage, as well as the great services like SageMaker, CloudFront, Content Delivery Networks, and Greengrass for AI and ML, so that they can use the cloud and our transparent pricing to deliver the things to the government that they need. And for both of those customer communities, you're now going to minimize the capital and the non-recurring expenses that you have to put into it. And you've got scalability so that with the one satellite system, you're only paying for what you needed for one satellite, and you can grow over time without having to change your ground architecture at all and only pay for what you use. So where are all these great antennas? we've been building, and right now we've got a ground station located in Oregon, very close to our government cloud in the west coast of the US. And then we've got our next ground station in the Ohio region, close to our eastern gov cloud. And then we've also got ground stations in Dublin, in Stockholm, in Bahrain, and in Sydney. And keep on checking our What's New blogs as this year goes by, because you'll see that we will be launching several other ground stations later this year in other parts of the AWS network. As you could see on the previous slide, those great systems are connected to a fiber network that connects all of AWS's regions and is managed by AWS. And the cool thing for our space customers is that now gives them what they really want to be able to build their mission and deliver data to the public and to the commercial sector customers. They've got elastic cloud compute, so you can actually start to convert your hardware modems and what they call in the satellite world to convert raw data into regular types of objects and information that people use, front-end processors. You could do all of that in the future on EC2, Elastic Cloud Compute. And we've actually been working with a number of vendors and customers so that they can get their products ready to operate in a virtual way on AWS. Next, you've got the ability to take advantage of our simple storage service, or S3, and all of our other mechanisms for storing data like Glacier, because you, in the satellite world, as many of you are probably familiar with, it's all about comparing data that you've had for years, decades even, with what you're collecting today, so that you can do change detection, you can find things that you didn't see before, you can compare the effects of disasters or environmental impacts from with what the environment looked like previously, and you can actually build a lot of great products. And so you store a lot of this data. So what better way to have that data accessible, but then put it in the cloud so that it's able to be moved anywhere in the world, or its products can be moved so that you don't have to move all that heavy data around to do your mission. Now you've got things like SageMaker and then AI and machine learning that we can help our customers use to automate the analysis of that data so that they're not having to look at that data and make decisions themselves. They're actually able to instead benefit from systems that can actually detect objects like swimming pools or building perimeters or town perimeters or bridges, and actually identify them, do before and after comparisons of data, building on that stored information I told you about, and then bring forward to the decision maker things that they wanted to pay attention to, like bridges or objects or specific shapes, so that they can use that to help feed their data analytics and tip and queue with the rest of the mission that they're trying to get done. And then you have things like CloudFront, where you can actually distribute data very quickly and efficiently around the world to all of your users in a seamless way using AWS services. So now let's tie that together. I wanted to show you some cool things that would combine AWS Ground Station with some of the hybrid architecture approaches that Evan just got done talking to you about. And the first one I'd like to show you is where we're going to be talking about pushing warfighter data to the edge. Now, I'm going to slow down a little bit because I wanted to save time to be able to talk about these two examples in greater depth for you. So we're working with over 80 different customers now using AWS to help bring these types of products to their customers through AWS Ground Station and over AWS. So they're collecting Earth observation data in this example. And for this community, I figured let's put a TEL down there, something that can go out and transport missiles, erect them, and then launch them. Something that's quite often, an interesting object that folks like me and you from the military have been wanting to track. So we're out there, a system tracks that data and comes over an AWS Ground Station region and is able to now downlink that raw data to the AWS cloud. Now, a lot of people who want that information, if they're not like in the hardcore realm of analyzing intelligence data or looking at open source information to find things, they just want to know what is an object and where is it and what is it doing. Those types of things can really be condensed and built into a compact message format that can be distributed around the world. So you don't want to move all that data to the edge. You want to be able to just give the benefit of that data to the people that need it in a quick, easy to use way. So you bring that data down to AWS. You use the services that I told you about earlier, like EC2, to actually turn that raw data into a product that can be analyzed. Then you can actually automate and orchestrate this data processing flow to move it into an AI or machine learning algorithm that's going to basically identify things, bring them forward, try to give them a correlation to what type of an object it is, and then input that into something that could start making inferences like, okay, this is close to another customer, it's close to a warfighter. We want to alert them to that, and we want to send them basically an icon with a representation of what the information is and an automated guesstimate or estimate of what the object is. At that point, we would move it back out of the AWS cloud to a relay system of your choice, and you would be able to then move that data through a direct connect to an antenna, get it back up to the relay, and then the relay could send it down to the warfighter in an RF format that they're already used to using, and using a satellite system, for example, like Inmarsat, that you're already using to do operations around the world, so that you could distribute this information to the warfighter. In the old days, that would have taken a long time, because you would have had to wait for this satellite system to get to its own ground stations, and then you'd have to wait for it to get moved to a processing area, looked at by an analyst, put into a messaging system, and then put up through the relay to your warfighters. In this case, you could actually automate it. The data could get from the downlink into the cloud in seconds. It could get processed in seconds or minutes, and then it could get moved in seconds again to the relay SATCOM Earth station, and up to the relay and down to the warfighter. And now you can use, like I said, geo satellites. You could use medium Earth orbit satellites like O3b to get that data, or in the future, you could take advantage of the broadband internet satellite systems that are coming to distribute that data to the world in seconds or even milliseconds. Next, let me talk to you about what do you do, though, if you just wanted to be fully contained. You're kind of trying to stay low profile, and you don't want to be able to have a transponded signal that you have to depend on. Instead, you just want to be able to receive data and use it. In this case, building on what Evan talked to you about again, you've basically got a Humvee or some other vehicle towing an in-theater mobile X-band antenna. That same Earth observation satellite that I told you about earlier could instead now be commanded through AWS Ground Station to downlink data to your location. And it would be encrypted. It would be all the same types of processing that you would do in the cloud or at its own ground station. But instead, you have your own antenna, and you could take advantage of a Snowball Edge cluster to be processing on maybe the optional NVIDIA instances, or just on some of our typical compute instances. You could have a software-defined radio and a mechanism for moving that data into the cluster in a lossless way. And now you could do many of those functions that I just told you about in your Snowball Edge cluster, using the compute and the storage, and then AI and ML types of algorithms to do the same type of analysis, and then data dissemination. And then finally, you can now take advantage of carrying around a snow cone, like Evan talked about, in a backpack, or using your own concept-equipped radios to move that data around the area that you're in, so that you can keep track of things, you can report threats, and you can keep people aware of what's going on. So in summary, by combining our hybrid architecture and many of the edge compute devices that Evan talked to you about with AWS cloud services and ground station, it allows you as a user to leverage a global network, take advantage of our infrastructure and security, use the cloud services, and only pay for what you need. So thank you all very much for your time. I appreciate everybody's attention, and look forward to questions after this presentation.